Hello children, welcome to Yamana's Physics. Today we are here to discuss the topic 2.3, section 2.3 of the lesson Electrostatic Potential and Capacitance. Here we are discussing the electric potential due to a point charge. In the last video, we have discussed what is electrostatic potential in detail. Now we are going to find out the value of the same thing for a point charge. And you know what is a point charge? Point charge means the size of the charge is much slow or small compared to the separation between any of the charges. That is known as point charge. So the definition goes like this, and this is the equation. This is the equation and the final answer, or this question has this answer. This written in the equation form. So what is that? Electric potential is defined as amount of work. So potential is nothing but work. For what? To move a unit positive charge from infinity to a point in the electric field without acceleration. So you are moving at a very infinitesimally small speed so that it doesn't get accelerated or acceleration goes to 0. And this is the equation. Now let us see how you arrive at this equation. For that, you should have the concept of electrostatic potential. Clear? So for that, this is the figure. You have a charge Q. Around, there is electric field. Around this charge, you have electric field. Now you have to find out the potential at the point P, which is at a distance r from Q. Now what we have to do for that? You have to take some amount of work. For what? To bring it from infinity to that point. So I am trying to take the unit positive charge from infinity, coming slowly and keeping at the point P. This is what I am going to do. And I need to find the work. Now for that, suppose in between infinity and P you have a point A. In between infinity and P you have a point A. Our unit positive charge is at that point A. And I am trying to move it through a small distance dx. So look at the figure. This part is very important. At the point A, electrostatic force of repulsion along right direction, and I have to move it along left direction. Means the angle between them is 180 degree. So electrostatic force right, dx left, theta 180. So what is the work? Equation of work is, if it is variable, the work is F dot x. The equation is F dot x. And we know by Coulomb's law, Fe is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. Here this is Q1, this is Q2, this is R square. So the equation goes 1 by 4 pi epsilon 0 Q by x square. And that is our F here dot dx, because you are taking it only through a very small distance dx. Not bar, need not write bar, F dot dx. This is bar, this is not bar. It's only a scalar. But definitely you need a bar because it's a dot product, right? Okay. Now, Fe bar into dx into cos 180. Cos 180, it is minus 1. So that minus I have put here, this is a magnitude 1. So you will have q dx divided by 4 pi epsilon 0 x square. And this dw is for taking it through a small distance dx, but you need the total work done, entire. So integrate means you are summing over from infinity to the point P. So take it from infinity to the point P means at a distance r. So find, this is the mathematics. Next is integration part. Finish the physics part is over here. So what is physics? This is physics. Taking a unit charge from infinity to the point P. That is all with physics. So let me see how the integration progress. So W is equal to, you are taking that minus sign outside the integral. The remaining values are inside. Infinity to R 1 by 4 pi epsilon 0 Q dx by x square. Now look at this, Q and 1 by 4 pi epsilon 0 are constants. Taking outside, the remaining value inside the integral is x square you have taken up, that is x raised to minus 2. Now the integration of the form integral x raised to n dx. X raised to n dx is x raised to n plus 1 by n plus 1. So x to the power minus 2 plus 1 divided by minus 2 plus 1 within the limits infinity to r. Again, this is minus 1, this is minus 1. This minus 1 and this minus 1. Outside already you have a minus just because of the opposite direction. Now this minus 1 due to integration, put it together, you will get it as plus. And x to the power minus 1 is nothing but 1 by x. Giving the limits infinity to r, you will get 1 by r minus 1 by infinity. So what is the value? V equal to, and this is the work. Actually this is the total work. But you know what is the total work? Work and potential are the same. So potential is given by the simple V. V equal to Q by 4 pi epsilon 0 1 by R, as 1 by infinity is equal to 0. Now this equation is for a positive charge here. If it is negative, what will happen? The same equation will hold good with a negative sign. Obviously potential is a scalar because it is dot product. Dot product is definitely a scalar quantity. So potential is a scalar with a minus sign. Why minus? You know, if this is negative, what will happen? Fe comes in this direction because it is attractive. Now it is repulsive. Only that's the difference. If it is minus, Fe comes in the reverse direction. So Fe and dx will be along the same direction. So theta goes to 0. Cos 0 is 1. So here it will be positive. But when you go to integration, you will have a minus sign. Here the both has this minus and this minus joins to form plus. But if that is the case, if this is negative, you will have only a minus sign at this integration point, not here. So finally you will have an answer minus q by 4 pi epsilon 0 1 by r. That's the only difference. So this is applicable for both plus q as well as minus q. Hope it is clear. Thank you for listening.